So we've been talking about circles and how to identify their arcs, angles, and segments using the relationships given in theorems, and we've been identifying the parts of circles compared in the theorems. Okay, so the circle that we have right here is called a secant length theorem. And basically what it's asking is if AC equals 12, so to start off, we're going to draw a line from A to C and put 12. And BC equals 3, so we're going to put a 3 here. And CD equals 4. Find EC. So we don't know what EC is, so we're just going to draw another line and put X. In this case, we're going to use our theorem, which states that we do a secant times its exterior angle and it should equal the secant times the exterior. Okay, so if that's our theorem, well, we have to identify our secants and our exterior. So we're going to have our first secant times exterior be 4 times x. And it should equal 12 times 3. Now, how I got x was that x is the whole secant. Since it was the whole secant, it goes where it has to be multiplied by 4, its exterior angle. Okay, and 12 and 3 is the same way. After that, you have to multiply, so you're going to get 4x equals 12 times 3 is 36. And then after you get that, you basically just divide. So you're going to divide both sides by 4. And then you're going to end up with x equals 9. So, EC equals, the whole secant will equal 9. Our next circle is an angle formed by a secant or a tangent. And how to identify this is that the vertex is outside of the circle. So it says to find ABD. So we're going to ABD. Well, in order to do that, you have to have the measurement from A to D. Okay, to identify that measurement, what we're going to do is we are going to add 132 plus 68, and you're going to get 200. And then you're going to subtract 360 minus 200 and get 160. So the arc from A to D equals 160. After that, you have to determine on what theorem you're going to use. Well, in this case, we're going to use angle equals arc minus arc divided by 2. So our two arcs are 68 and 160. So what we're going to do is we're going to do x equals 160 minus 68 and divide it by 2. And you will get x equals 46. So the measurement of angle ABD equals 46. Okay, our next circle is a angle formed by a chord. And how to identify that is that the vertex is inside of the circle. Well, you have to find the measurement of angle BCE. So we're going to highlight that in yellow. Okay, once you identify what you have to find, you have to figure out what theorem you're going to use. Well, in this case, we're going to use angle equals arc plus arc, and we're going to divide it by 2. Okay, so you have to find angle BCE. Well, the arc of that angle measurement is 134, but you have to find the arc of angle ACE to match, to figure out what the angle is for the arc of 134. So to do that, we're going to add 134 plus 96, and then add 54, and you should equal to get 284. Once you determine that, you have to subtract it from 360, so we're going to do 360 minus 284, and you should get 76. Okay, so after that, we're basically going to put it in our formula. So we're going to put x equals 134 plus 76 and divide it by 2. Once you divide it by 2, you should get x equals 105. So the measurement of angle BCE equals 105. And don't forget, you can always go back and look at your notes if you have to. We have a flip book and we have the written out notes on the paper that is titled Circles Part 2, Arcs, Angles, and Secants. If you have any questions, just ask and don't be scared.